Okay, what is the value of x if you know y is 8? So we know y is 8, and here's our equation right here. You and I know y is 8, so how can we figure out x's value? Well, you just told me y's value is 8, so I know that 2x plus 8 is 20. I just substituted in the value of 8 into that y. Now I can solve it. I subtract 8 from both sides. I get 2x equals 12. And now I divide by 2. I can find it to be 6 because all I did is I substituted in. You told me y was worth something, so I plugged it into the equation. So we simply substitute the y value to find out the answer. So if 2x plus y is 9 and we knew y equals 2x plus 5, what could we do then? So we have this equation they gave us. And instead of saying y equals 5 or 6 or 7, it gave me an expression. Well, no big deal. I'm going to take that 2x plus 5 and plug it right into that y. Because then what happens is you no longer have y's, you have the whole equations with x's, and then you can solve it. So I'm going to say 2x plus, instead of y, we replaced y with what? 2x plus 5. With this, what it said y was worth. If it said y was worth 10, we would have put 10 there. But it said y was worth 2x plus 5. So that's what we put there. Now this equation equals 9 according to what we have right there. So now I put my x's together, move my 5 over, and I find out 4x is equal to 4. 4 times what is equal to 4? Well, divide by 4 and we see x is 1. We simply use substitution. So here we have a system of equations. It says the two equations they gave us, y is equal to the opposite of x plus 5 and x plus 2y equals negative 2. And it's like, hey, figure out what x and what y happen to be here. Now, what we're really looking for is a point of intersection. You have two lines and you're trying to find that point where they're crossing that's on both lines. So here's what we're going to do. As soon as I see y equals, I know it's substitution. I know that I'm going to take, if it had said y equals 10, I would have plugged 10 into the other second equation. But I'm going to plug that opposite of x plus 5 right into that y right there. So we have x plus 2 times y. What is y? Y is worth x plus 5. That's the expression that represents y's value. And that equals negative 2. So we need to distribute the 2 here. So we have x plus 2x plus 10 is equal to negative 2. That gives me 3x plus 10 is negative 2. Subtract 10 from both sides. 3x equals negative 12. Divide by 3. X is negative 4. Now you can't stop there because you got to remember, you got to figure out y's value too. We're looking for a point of intersection. So all I got to do is plug x negative 4 into either one of the two equations. I'm just going to go back to the y equals equation. Y is equal to the opposite of x. So what's the opposite of negative 4? So the opposite of negative 4 plus 5. With the opposite of negative 4, that's a plus 4. So y is 9. There's my solution. X is negative 4, y is 9. That means they intersect at this point, negative 4, positive 9. That's where the two lines would be crossing. Let's look at another example. Here it says x is equal to 9 minus y. As soon as it says x equals or y equals, I'm using that, I'm substituting that into the equation below. So I substitute it into that x right there. So we have 2 times x, which we know is worth 9 minus y, and that ends up equaling 2y minus 6. Distribute through, 18 minus 2y equals 2y minus 6. Now what do? I'm going to put all my y's together. I'm going to move the smaller piece, so I'm going to move this guy over. You're used to moving things over to the left. Doesn't matter. If you want to do that, you can. This gives me 18. That goes away. 4y minus 6. Add 6. I get 24 is equal to 4y. Divide by 4. You're going to get y is 6. Y is 6. Still need to know x's value. So I'm going to go back. I'm just going to go to the first equation, x is equal to 9 minus whatever y is 6. So x is 3. There's your points where they cross. It crosses at x is 3, y is 6. The ordered pair, if we want to write them as an ordered pair, 3, 6. System of equations starts off y equals, boom, I'm going to use substitution. I'm going to plug 3x minus 5 into the y below. So we have x minus 3 times 3x minus 5, and that equals negative 1. I distribute my 3 through. That gives me negative 9x plus 15 equals negative 1. That gives me negative 8x plus 15 is negative 1. Subtract 15 from both sides. Negative 16 divided by negative 8 gives you positive 2. So x is positive 2. How do we find y? Plug into either equation. I'm going to plug back into the original equation, the first one, y equals 3 times x, which is 2, minus 5. So y is 6 minus 5. Y is 1. X is 2, y is 1. We could write them as the ordered pair, 2, 1. That'll be the point of intersection. One more example for you. This one sometimes gets students. It says y equals, and the other equation says y equals. Well, as soon as I see y equals, I'm going to substitute that right into the y there. That's what I'm going to do. So let's substitute it in there. So I get 2x plus 1 is equal to 2x plus 5. Okay? If you ever an equation y equals and the other equation's y equal, they're going to be set equal to one another. Now, what happens here? This is a special case because notice when we subtract 2x, we get 1 is equal to 5. The x's totally disappear. Now, that's going to happen sometimes. When it happens, you have two situations. You're either going to get a false statement or a true statement. In this case, we got a false statement. That tells me that what is happening here is the two lines never have a point that they share. In other words, they're parallel. They never intersect. They're parallel. So that tells me there's no solution here. So you always have three options. The lines can cross and have an intersecting point. They could be parallel, or they could be the same line. And then everybody works. If that happens, you end up with a true statement like 6 is equal to 6 or 0 is equal to 0. That tells you that it's true. That means everybody works. Okay, that means there's all solutions work. All real numbers work for it. It's going to work all because basically the equations are the same thing. So in this problem, we ended up with a false statement. It meant they were parallel, which told me nobody works. There's never a solution, so no solution.